Hey everybody, it's Matt from Eastwood Company and welcome to another edition of Eastwood Tech Videos. Today we're talking about aluminum welding. There's a bunch of different ways that you can weld aluminum, but today we're going to cover probably the most popular two ways, and that's TIG welding and MIG welding. We're going to start off with the more difficult of the two, TIG welding. TIG welding is a more difficult process. It's sort of like oxyacetylene welding, in which you have a torch, a flame, and you have a filler rod that you're adding to it. So before you start welding aluminum with a TIG welder, I highly suggest learning the basics on steel, and then you can start jumping into aluminum. So today, I'm going to just kind of fast forward and assume or hope that everybody that's watching this at least has a general grasp on how the TIG welding process works. We'll jump right into it. So with TIG welding aluminum, there's a couple key things you need to do that makes you a success, allows you to get a successful TIG weld on aluminum. Probably the number one most important thing is keeping the metal clean, keeping everything clean, really. Aluminum welding and TIG welding in general really needs to be as close to surgically clean as you can get, especially on aluminum. So when you're starting with a fresh piece of metal, this is one that we just have, a brand new piece of metal. You can see on the back side here, it looks pretty darn clean. I mean, there's no huge grease spots on it or anything really offensive on the back of it. But in reality, that's a special coating they put over the top of the metal to keep it from corroding while it's just sitting on the shelves. That coating you cannot TIG weld through. It's gonna cause a dirty weld. It's gonna pop and sputter and cause some issues. So what I've done on the other side here is I've cleaned the metal off. I used just today, really quickly, one of these little angle grinders with a 36 grit on it. If it's something that's a thinner grit or something you don't want to use as aggressive of a sanding disc, you could definitely use a DA sander with 80 grit or 120, or you could downgrade to a 120 or something for one of these discs. Even one of the little cookies, the like abrasive discs work as well. So I've hit this with the 36 grit. And you can see it's a little bit different of a shade of metal on there, and that's a clean metal. Now what happens is if this metal sits, if we clean this metal and leave it sit for a couple days, or if it sits for a month, on the molecular level, this is starting to corrode. It's getting corrosion just from the atmosphere, from the air. Even while I'm holding this, it's happening. Is it enough to cause an issue while we're standing here? Probably not. But if it sits for weeks, months, definitely at that point it could start to cause an issue. So what I always suggest to do, a good tip, is every time before you go to weld aluminum, is take a stainless brush. I like to try and keep a dedicated stainless brush just for aluminum, and then a separate one that I would use for steel. This one for aluminum. And I would go over this piece here with the wire brush where we're going to weld, just to knock any potential corrosion that got on the surface just from when it's sitting around, or potentially if something just got on you, dropped on your workbench or something dirty there, you can take any of that off. So that's how to prepare the piece, a real quick way. If you want to really get it as clean as possible, the pre-painting prep. Our low VOC, that's the key thing that I do want to mention. You want to use our low VOC pre-painting prep, where you can use straight acetone or simple green or something like that to clean your part. Do not, under any circumstances, use a heavy-duty cleaner like a brake clean or a chassis clean or something that's aggressive like that, or carb clean. They have an ingredient in them that leaves a residue on the metal that even after you wipe it off and let it flash off, there's a residue that could potentially be on the metal. When you burn, where you start melting the metal, it burns that residue, and it creates basically what is mustard gas. So it's obviously very harmful. Don't want to breathe that in. So if you make sure you use a low VOC formula like the straight acetone, or simple green or something like that, a less aggressive cleaner, those ones are all okay and they'll flash off and it'll be just fine. So again, that's cleaning it. So TIG welding aluminum, there's a couple key things. With TIG welding aluminum, you do need to use 100% argon. Pretty much all TIG welding you need to use 100% argon. The other thing is you're going to flip your machine. If you have an Eastwood machine, right here, this switch here, you're going to flip it over to the AC side. You should be familiar with the amperage here, your pre and your post flow. I like to crank the pre-flow up a little bit higher, and the post flow I like to crank a little bit higher as well. So I have that turned up a bit from where I would weld on steel. The reason being is that with aluminum, it has a lower melting temperature. It's going to solidify a little slower. You need to keep your torch, and we'll show you in a little bit, held over the area, the last dab of weld that you put in. You need to hold your torch over for the post flow to allow that metal to cool, solidify, and you keep a little bubble of shielding gas around it. So that's why that's really important to make sure that your post flow is turned up a little bit. The other dial that's pretty important here is the clearance effect. Some machines may call this a balance control. On our machine, it's called a clearance effect. Essentially what you're doing in a short version of this, you're changing the sine wave that's coming out of the machine, going from positive and negative. There's a sine wave that's going up and down. By playing with this dial, you can basically make the sine wave hang to the positive or the negative side. So it can hang for a split second or two longer. What this means to you, why you care, that basically changes it changes the size of your puddle and how much the machine actually cleans, how much the torch cleans. So when you're welding aluminum, there's an additional process that does not happen in steel, on which it's actually cleaning the metal before you start actually adding filler rod to it. So with this, by turning it more negative, you're going to get a narrower, more narrow puddle that's going to clean less. So the more negative it is, the less cleaning you're going to get. The more you turn it towards the positive side, the more your puddle is going to get wider, but you're going to get a larger cleaning area. This is important if you're welding different types of aluminum. If you're welding a part that's actually on a car, that was on a car, it may just be a casting that's a more dirty aluminum. The way I always describe it is if you're welding a part that's off of a 1920s car, a piece of aluminum that's from 1920s, they obviously used a much poorer quality than if you were welding something that was from a 2010 Mercedes. They're going to use a lot nicer aluminum, so you may have to change your clearance effect or your balance control to compensate for the quality of the metal. So with what we're welding today, this is fresh, clean aluminum. I'm using what's called a gas lens here. Let me just pull my torch out. So I'm using a gas lens setup, which uses a little screen on the inside. This gas lens setup is much more efficient with the gas coverage, the shielding gas coverage over the area that you weld, which means that you can get away with, which means it cleans better, and you can get away with running a little more towards the negative side when you're welding aluminum. So for this, what we're welding today, I'm going to stick to -3 for the clearance effect. I could probably even drop a little bit lower if I wanted to, but for what we're doing today, that's a nice safe spot. So if that's all set up, we'll check our cords here, make sure everything's tight. We got all that good. All right. So we have our argon, like I said, 100% argon set up, and I'm going to put on some safety equipment here, the helmet and the gloves, and I'll flip the machine on. And we're just going to show you the process for TIG welding. I'm going to try and talk you through it as we're doing it because I feel that it's better to kind of see rather than listening to me go on and on about it. I think you guys can learn a little bit by just watching the process and seeing what it's supposed to look like. So we'll get our gloves on here. Now you want to match your filler rod as close as you can to what you're welding. The filler rod that we offer is a 4000 series, so it's a ER 4043. So that's the type of aluminum. Any TIG wire that you get is going to have a the type of filler material that it is on the top there. So an ER 4043 is a good all-around filler wire. You can use this for most, I should say, most all repairs. You're pretty safe with using. Now there is going to be instances where you may have something that's a much different grade of aluminum that you may have to upgrade or upgrade your filler wire to match more closely what you're welding. So we got our shielding gas on, and I'm going to sit down here. So before I actually start welding, I'll show you, so what you're going to want to do, move this all over here. When you start welding, we're going to actually hold our hand, our torch, in the same spot for a beat or two, for a second, a couple seconds. We're going to let the torch clean the metal really well. You'll see that there'll be like a white halo that will the arc will dance around and kind of put a white halo around where we're welding. Once you see that forming, then you can start giving it a little more throttle, a little more pedal, a little more amperage, and you'll start to see a shiny puddle open up. Once you start to see that shiny puddle open up, that's when you're about ready to add filler rod. A common mistake that we see people make is that they, as soon as they start the arc, they start adding filler rod. With TIG welding, you need to kind of wait, let that puddle open up, then you can add your filler rod and start moving. So I'm going to be clean. All right. So let me just start here, and then I'll kind of talk you through it. You let me know when you're ready, Joe. So as you can see, it's kind of dancing around there. I'm giving it more throttle. It's getting a little shiny there. Now I can add my filler rod. I'm just adding filler rod and moving. You can see that white halo is kind of following where I'm welding. And I am pumping the pedal a little bit. That's to kind of keep my heat in check. With aluminum being such a heat sink, I definitely want to make sure that the piece doesn't get too hot and we don't blow through. So I'm just kind of going along, and that's why you hear that amperage. The sound is kind of changing as I vary the amperage of my foot. Alright, now here at the end, I'm going to back off real slow, add one last dab of filler, another one. Hold my torch over there, hear it. Now once you hear that stop, that's when you can let off. So we had a little bit of a brown halo that you see there at the end. That means that there was a little bit of contaminant on this. It could have been just from my fingers touching this. It could have been a little bit that showed up at the end. So again, if you really clean the part and you're religious with it, you can really get a surgically clean piece, and you won't get that little brown halo there. For what we were doing here, I probably should have just wiped it off, but it doesn't hurt anything, again, for just demonstrating the process. But you can see on this piece here, can you see that? Or I'll flip it up here. You can see the white halo that's kind of around our whole entire weld. That's the cleaning area that we were talking about. So if we turn the setting, if we turn that setting up more towards the positive side, so if we go from -3 to say -1, this puddle is going to open up quite a bit, and you're going to see that halo open up quite a bit as well. So that's the you have to play with that dial to get the sweet spot as you're learning. Now, if you don't have the interest or the money to buy a TIG welder, to upgrade to having a TIG welder, have multiple machines, probably the most simple way that you can get going with welding aluminum is you can use your MIG welder. With the MIG welder, you do need to convert to a spool gun. So this is an aluminum welding spool gun. So the reason that you need a spool gun, it actually has the spool up in here, as it would suggest by the name. The reason you need this is because the aluminum wire is much softer than the steel wire. So if you put the aluminum wire in the machine and it has to travel all the way through your torch lead, you would basically have the wire bunching up within it because it's just too soft of a wire. So with the spool gun, you have your wire right here, and it only has to travel a short, straight distance to come out of the gun, and you're welding. So this method of welding aluminum is probably one of the more, as compared to TIG, it's a little more messy. It creates sparks and spatter like a MIG welder does. But if you tune the welder up, and there's a couple key things you can do, it can help you make some pretty good aluminum welds. And as with anything, if you practice, you can get pretty good with it. So to convert this over, at least on the MIG 175, like we have here, it's really simple. You would pull your torch lead out, and you unscrew your plug here, your trigger switch. You pull that out, and put the spool gun in, tighten this down, and then inside the machine there is a little switch that you switch it over to spool gun, and that'll allow you to weld with the spool gun instead of with normal steel welding with the torch. So that'll let you activate it in here. So with welding aluminum, a big thing that we see, at least with the spool gun, that people kind of forget is with MIG welding with steel, you can get away with welding something that's kind of dirty, may not be clean the best. I know I've done it, and other people do it all the time. And something might be a little rusty, or there might be a little bit of primer left over. You can kind of get away with burning it off, and it works okay. With aluminum, to get the best foot forward, you really need to clean the part as good as you possibly can. Take the extra time to really clean the part down, especially with MIG welding versus TIG welding, because you have a little less control over what the arc's doing to get any type of extra cleaning advantage. You don't have that with a MIG welder, so you need to clean it really well. So what I've done, is I've taken this little angle grinder here, 36 grit, and I've sanded this part that we're going to weld here, this little weld joint. And I've sanded just the areas that we're going to actually be welding on the inside there. So one thing you want to do before we actually weld it, you want to at least hit it with a wire brush, a stainless wire brush, to clean off the area you're welding. Might clean any minor contaminants off of the piece. It could have got on it from it sitting, so we're going to do that real quick. All right. So if you want to take it a step further, you can use the low VOC pre-painting prep or 100% acetone or a mild cleaner similar to that. Is completely acceptable to use in this case. But to save the time of letting that flash off, we're just going to get going here, let you guys see. It's going to be difficult for you to see the actual welding process because we're kind of blocked here, but you should be able to see and hear the sound of what it's like when it's welding, and then we'll flip it around and let you guys see exactly what it looks like. Now, one thing you may notice, you may or may not notice, is that you need to move really quick when you're welding with a spool gun on aluminum with a MIG welder. There's no stopping. You got to, as soon as you start melting, you got to start moving really quick because it wants to heat up and burn through, no matter what your settings are. So to be in that optimum heat setting and wire speed, you need to really move quickly. You got to really identify that puddle immediately and start pushing it along. So with the settings, they're kind of, if you're used to what you see on when you're welding steel, MIG welding steel, it's kind of a lot different. You might see here we got the wire speed pretty much maxed out, and we got the machine turned up about halfway, I'd say. It's like E1/2 is the setting there, and I got the wire speed maxed out. That's because we need to get as much wire as we can down into the piece to melt, to create that arc and melt the two pieces together. So I'm going to start this up here. We're going to lay a weld down, and then I'll flip it over and let you guys check it out. All right, and we're gonna start moving here. You could probably see I was moving really quick there. I wasn't sitting in one spot at all. With this, one thing I did forget to mention, you do need to have 100% argon. So when you're welding aluminum with the spool gun, you need to switch it over to 100% argon. You cannot use your mix bottle, your CO2 argon mix bottle. Cannot use that. You need to use 100% argon. So if you have the MIG welder and the spool gun, I would at least keep a small bottle on hand. If you're doing a little bit of aluminum welding, keep that on hand so you can switch the bottle out. Only takes a few seconds. So here you can see, before I've wiped anything down, what it looks like. You can see there's the black soot around the outside edge there. That's just the dirt and contaminants that are popping off. It's kind of a not nearly as clean of a weld as you would see with TIG welding. So with this, we should see on the back side, you can see it was starting to, this is pretty warm here. We were dancing around burning through there. You can see some little spots where I was starting to get all the way through. So that's what you're fighting that whole time. The other big problem is aluminum is a heat sink. So as you're welding about halfway through, the piece is going to start heating up. And with a MIG welder, there's no way to vary the heat, so you need to move faster. So as you start welding, you actually need to move quicker as you get more to the end, because the piece is heating up. You're at a greater risk of burning through the piece. So you really gotta keep an eye on the penetration that's happening with your weld so that you don't burn through. It's really important on MIG welding. So I'll hit this with the wire brush here. I'll show you what it looks like after you're done. All right, so there's a little view of our the aluminum piece we just ran. So you can get a similar effect as welding steel with aluminum. It takes a bit of practice. I'll admit I'm a little out of practice because I can TIG weld, so I don't pick up the spool gun as often as I should, but it's still really great to use. The spaces, the times that I'd use a MIG spool gun over a TIG welder, you can get into tight spaces that you may not be able to get into with a TIG welder. If you're welding something you just can't get clean enough, a TIG welder, you'll probably fight it and won't be able to really get a weld. With this, you can at least get away with something that's a little dirtier. You can still at least get a weld. It may not be as pretty as you'd like, but you can still lay a weld down in somewhere that a TIG may not be able to at all. So it does have its advantages, and also, obviously the advantage is that you don't have to buy a different machine. You can just have your spool gun on hand, and you can use your MIG welder. So that's the basics of what it looks like, what it sounds like to weld aluminum with a MIG welder versus a TIG welder. I hope you guys learned something. If you have any questions or have any ideas for future tech videos, be sure to leave a comment on the video here, or drop us a line through email. And make sure you follow us on Facebook, Twitter, Instagram, and subscribe to our YouTube channel here to get any updates on any future videos we do at all. Thanks for watching. We'll check you next time.